Alright, welcome to today's video on the Coase graph. Today we're going to be looking at the Coase theta graph, the basic Coase theta graph. And theta stands for any angle, so you can call theta anything you like. And what we're going to be looking at is to trace out this Coase graph across the time intervals of 90. So we're going to have 90 over there, 180, 270. 360. This graph is not to scale. And so what I need to do first of all is ask the calculator, which is this one I have, is a T184 plus CET, but it's out of batteries. I'm going to use my laptop. I'm going to ask the calculator, Coase 0, what is that equal to? Well, Coase 0 is equal to 90. And don't forget, if Coase 0 is 90, so if Coase 0 is equal to 1, if Coase 0 is equal to 1, then that must be on the axis over here. 1 must be up there. Because the value of x is 0, as in Coase 0, and Coase 0 is equal to 1, which is the value of the y value. Right, so far so good. That's 0 over there. What is the value of Coase 90? Coase 90. The value of Coase 90 is 0, which is on the x-axis. The y value is 0 on the x-axis. So we start from up there, go down there. Right, the next 90-degree interval, what is the value of Coase 180? Minus 1. Right, so we have minus 1 down there. And so what we're going to do is go to some point over here. The Coase of 180 degrees is equal to minus 1. And so I have the correct color. Just turning over there. Here's my turning points. Next value of 270. Don't forget 90-degree intervals. Every 90 degrees. Coase 270. Is equal to 0, which is this point on the axis there, up there, it's nice and smooth and even. And what is the value of Coase 360 degrees? And that is equal to 1, which is roughly up there, to do with that one value there. And so we have a nice little thing there. So that is your Coase graph. Drawn very nicely for you. You can do that if you want. And you notice one very important thing about the Coase graph. It starts at 1, goes down, and goes up to 1 again. Goes down to -1, of course. And that's the difference between the Coase and the sine graph, is that they start at different positions. Their shapes are indeed similar. Right, if I were to look at a Ferris wheel example, again, I need to draw my intervals here, 0, 90 degrees, and 90 would be pi over 2 if you're dealing with radians. Those of you who know the unit circle. 180 degrees over here, or pi. 270 degrees, or 3 pi over 2. That's 3 pi over 2, and writing's a bit smudgy. And this is 360 degrees, or 2 pi. Alright, so as you saw earlier on, when we did the entire Coase graph, we asked the calculator, what is the Coase of 0 equal to? And the Coase of 0 was in actual fact the value of 1. Let's just double check that. We can see it in our graph as well. The Coase of 0 was in actual fact 1. So starting here, if that's 0, this will be 1 there. That 1 value there. Then we ask the calculator, what is the Coase of 90? And again, I told it that is 0. So, strictly speaking, we should be kind of starting off up here. And we can go around and around the clock, and then of course, just as we did with the sine graph, you would then go through all your values and be able to get a nice little circular thing. Watch my video on the sine theta, because this just adds to that particular video, and we don't want to labor and repeat this point anymore. Anyway, that is the sine and the cos graph all covered. Look at my other video and have a good day. Thank you. Bye bye.